So today we will talk about human-centric explainable AI approach in healthcare, but I will tell you a little bit before about me and why we need a human-centric AI. But I'm sure now you know more than me that all these models that we've been seeing, all these days, all these models, we ask them to predict. So they are predictive models, but they are black boxes. So I don't know if you've heard this word before. We will go through it, hopefully, and I will try to connect and approach this from different angles, from the ethics angles tomorrow and from the creativity entrepreneurship the day after. So, but the question becomes like, is it easy to break into black boxes? Because we really need, to understand, like, how do they function? How do they predict, and how do they make decisions, So coming to this, I care very much, in my lab about how to communicate this to the public, how to communicate this to non-experts, how to communicate this to policymakers, because we really need to connect all these dots together. So I have a great artist, working for me, and in this allegorical representation of a human to the left and the alter ego, the AI, which is a perfect deputy, if you want to call it, a partner. We will see, if we want this. And it's a nice representation of these green and turtle like branches of the plants, that it's a feedback loop, that we can learn from each other. And they interact with each other because we want them really to help us mitigate bias, perform better, and give us some like ethical and responsible, output. So we use this hopefully to be more effective in science communication. So we will be talking about what's this about human-centric AI, because we proposed this to the editor of Transplant Science. It's the best journal in our area, and it's been very tough, to go through. But this is already there, and it was featured on the cover. So please, if you want more details, if you want to learn more, go to those papers, that I will be showing you. So now, of course, all of these things, AI, the one what we've been hearing, because,
for example, identify 9 with 97%. And based on the algorithm goes through or rectuning, then we learn more and better. If we can.
So we will be you will be comparing the network. Then we always don't open the picture.
If we can go to the next slide. Okay, so after training, we go to of the model, so to images from the test set. The test image goes through the trained model, and we get a classification whether it's not. Hold matrix. In this case, we achieved 9 almost a bit more exercise, and we will see how we get this result. Next slide, Doctor. Okay, so we thought the black box, but how to make it explainable? We took the same convolutional neural algorithm and added the prototype layer. So during training, the prototype layer extracts important images. We call these parts, and they represent the features that these convolutional layers are learning. Evidently, the model is learning. So the model learns a similarity metric between these. And based on a similarity score, we pick a class based on the weighted sum of the similarities between the prototypes. So some of these prototypes, the nearest patch and similar prototypes, they come from differences. So these often correspond to types. And thus we prune them, so we omit those prototypes from the model. And finally, once the training for interpretation or to generate explanation, once we input a test image, the model tries to find evidence the test image belongs to a specific class, bases it to all the prototype it has learned, and marks the activated patches in the boxes. So these are very similar to what prototypes this model has learned. The heat maps show us which part of this image is similar to a prototype.